Now, let's try to solve a few of past year questions to enhance our understanding on Gauss-Seidel iterative method. For the first question, we will look on April/May 2011 exam questions. The question asks us to compute the values of x1, x2, x3 after 3 iterations in the Gauss-Seidel method for the following system using x1 equal to 1, x2 equal to 3, and x3 equal to 5 as the initial guesses. To solve the problem, firstly, we must check the diagonality of the coefficient matrix. Here, we have the magnitude of A11 equal to 12, which is greater than the sum of A12 and A13, that is 10. We also have the magnitude of A22 and A23 that is greater than the sum of the magnitude of all other non-diagonal entries in the respective row 2 and 3. So, the coefficient matrix is diagonally dominant. Therefore, we know that the solution will converge. Next, we rewrite the problem that we want to solve into 3 linear equations. To solve for x1, x2, and x3, we put the rest of the expressions on the right-hand side. Now, we can apply the Gauss-Seidel method. Let x1 equal to 1, x2 equal to 3, and x3 equal to 5 be the initial guesses. We first solve for x1 in the first equation and find that x1 equal to negative 2.8333. We then solve for x2 in the second equation using the value of x1 and all value of x2 and x3. Finally, we solve for x3 in the third equation using the new values of x1 and x2. Then, we will obtain the value of the first iterations of the Gauss-Seidel method. For the second iteration, we will use the values from the first iteration and the new values of xi as soon as they are computed. For example, x2 in the second iteration will use the values of x1 from the first equation from that iteration. We do until third iteration using the same step as the first and the second iteration. Then, we summarize the solution into a table to get a better view of the solutions. To obtain the final solution, we run off the values of the and we obtain x1 equal to 1, x2 equal to negative 1, and x3 equal to negative 1.
Created using Powtoon.